Myself, Dr. K. Viswanath Allamraju, Institute of Aeronautical Engineering, Department of Mechanical Engineering, Hyderabad. In this session, we are going to study the deflection of a simply supported beam with an eccentric point load. So here, a simply supported beam is considered at support A and B, having supports, and eccentric load is acted at point load. Concentric load is acted at a distance of A from left support. So here, what is the meaning of eccentric load? Eccentric load means the concentric load which is acting not at the center of the beam, then that load is known as eccentric load. In another manner, we can also call it as eccentric load means the concentric load is not at the center. Either it can become closer to left support, or close away from the left support, or closer to right support, or away from the right support. Now in this case here, the concentrated load W is acting the larger distance from left side support A, and from right side support B. Here A is greater than B. Now the reactions are calculated from the concepts of shear force and bending moment diagrams. So we considered by using two equilibrium equations. One of the equilibrium equation is sigma Fy equal to 0. Another one is sigma M A equal to 0. By using these two equilibrium conditions, we calculated the reactions at support A and support B. The calculated reactions at A is W B by L, and at B it is W times A by L. Now we have to find out the reaction at section X. So now consider a section X at a distance of capital X. Okay, from in the length of AC. The bending moment at this section is given by, that is Mx equal to Ra times X. The the value of the Ra is Wb by L times X. Now here the plus sign indicates it is sagging. So it's the positive bending moment. We know the equation already. The variation of the bending moment at any section is M equal to Ei times d square y by dx square. Equate the Mx with this M equation. Now then the value of becomes then Wb by L into X equal to Ei times d square y by dx square. Now this is the equation. Now here, if we integrate this equation once, then the equation obtained is known as the slope equation. That is Ei times dy by dx equal to Wb by L. X integration is x square by 2 plus c1. This equation is known as the slope equation, but here the c1 is the constant of integration. Now integrate above equation, that is the slope equation. After integrating the slope equation, it becomes deflection. Ei times y equal to Wb by 2L x cube by 3 plus c1 x plus c2. The c1 and c2 both are constant of integrations. This constant of integration can be calculated by using boundary conditions. The boundary conditions, we need two constants. So two boundary conditions are required. The first boundary condition here it is at support A, x equal to 0, the distance equal to 0, then the deflection y equal to 0. At C, that is at point C, the distance x equal to from left side support is A, and the slope is dy by dx equal to theta c. So here the theta c is unknown. Now by using the first boundary condition at support A, x equal to 0 and deflection y equal to 0, substituting these values in equation 2, then the value of the C2 will be obtained. So at x equal to 0, that means this term becomes 0. and C1 also becomes 0. The term at y equal to 0, that means C2 equal to 0. Substitute back in the equation 2 again. In the place of C2, the equation of 2 will be converted into 3 by substituting the constant of integration C2 equal to 0. Then it becomes EI times y equal to WB by 2L into 3, that is 6L times x cube plus C1x. Now, after here at a C point we need that x equal to A and the slope dy by dx, that is theta c. So the value of C1 is obtained by substituting these values in equation 1. Again in equation 1, if we substitute here this boundary condition at x equal to A, this is dy by dx, that is related to slope. The equation 1, here it is. This is the equation 1. EI times dy by dx equal to WB by L times x square by 2 plus C1. In this dy by dx equal to 0, dy by dx is not 0, that is theta c at c, x equal to A. Then the equation is converted, the slope equation, now it is converted in terms of values distance A. But from this equation C1 can be calculated. Now that is C1 equal to EI times theta c minus W by WB is A square by 2L. Now we know the equation, substituting the value of C1 in 1 and 3. If we substitute, this is the 3 equation, the C1 and also this 1 equation. So because we calculated C1, now the equations becomes this transformed into by after substituting the value of the C1, it becomes equation 4 and equation 5. The equation 4 is that EA into dy by dx equal to W by times WB by 2L times x square plus E1 EI theta c minus WB a square by 2L. Now again another equation is there in this equation, that is equation 3. If we substitute, then in terms of x, that is EI times y equal to WB by 6L x cube plus EI theta c minus WB a square by 2L times x. Now this equation is the slope equation and it is the deflection equation. But these are not still complete. Why? Because we have to know the value of the theta c. After substituting the value of the theta c, then only the complete equations can be calculated or can be observed. Now here how to get that theta c. Now the equation 4 gives the slope, yes, whereas the equation 5 gives deflection at any point in section, the part AC. But the value of theta c is unknown here in the section part in this AC. But provided the value of theta c is required. If we know the value of theta c value, after substituting in this equation 4, then the slope can be observed. After substituting theta c in equation 5, then the deflection can be calculated across the section, across the length span AC. Now how to calculate that AC portion? Now theta c is unknown. Now we have to go for the second case. From that second case, the theta c will be obtained. From the theta c after substitution back, then we can know the complete deflection and slope equations of a simply supported beam with an eccentric load. Now in this case, now considering the section between CB. Now before case A up to A to C. Now here it is up to AX, that is means up to C to B. Between CB. Now X varying now here. X varies from A to L. Now the beam at this section we need bending moment. What is that? Mx equal to RA times X minus W into X minus A. This distance will come. So this RA times the positive sagging portion, this W, this is the hogging portion. So that's why negative. So what is the sign conventions as a part? This is the positive bending moment, and here it is the negative bending moment. These are the sign conventions of a bending moment. So in order to understand simplification, the positive bending moment, yes, it is the smile. This is the positive, and the negative bending moment is the, if you make it negative bending moment. So if the position is a smiley position, the positive bending moment is the sign convention, and negative bending moments. Now here, if the movement in this positive direction, the slope WB by L times X, that is the positive bending moment, that is RA times X minus W times X minus A. This is MX equation. Now, after knowing this equation, we know the bending moment varying across the section, that is m equal to I times d square y by dx square. Yes. So equate that mx with this equation, then you can see that ei into d square by dx square equal to w by times x by l minus w times x minus a. Now again, if we integrate once, then we'll get it the slope equation, and if we integrate again slope equation again, then we'll get a deflection equation. But here the constant of integration is c3 in the slope equation. In the slope equation, the constant of integration is ei times dy by dx equal to wb by l x square by 2 minus w times x minus a whole square by 2 plus c3. The c3 is the constant of integration. Again, integrate this slope equation, that is eiy equal to wb by l x by 2l x cube by 3 minus w by 2 x minus a, that is x minus a whole cube by 3 plus c1 c3x plus c4. The c3 and c4 again constant of integrations. How to find out? By using again two more boundary conditions. The first boundary condition is at x equal to l, at b, that at support b, what is the slope equal to 0? This y equation, where is the y here? In equation 7 if you substitute, because y where it is in equation 7, y equal to 0 and x equal to l, wb by 2l times l for l cube by 3 minus w by 2 l minus a whole cube by 3 plus c3l plus c4. Now c3l plus c4, that is the seventh equation. After simplification, from that c4 will be obtained. The c4 is obtained in terms of c3. Now by using second boundary for next boundary condition, that is at x equal at c, x equal to a, again dy by dx equal to theta c. So from this again theta c is unknown. Now ei times, substitute again, where is that? Now we have to integrate. Now substitute this dy by dx theta c in x equal to a in equation number, what is that equation here? Dy by dx, that is the slope equation. Substitute in the place in the slope equation, then we can observe the c3 in terms of slope theta c. So ei times theta c equal to wb a square by 2l minus w by 2 a minus a whole square plus c3. This term becomes 0. Then c3 equal to, in terms of slope c, that is ei theta c minus wb a square by 2l. So c3 substitute back again where deflection equation, slope equation, c3 and c4 and the deflection equation. Then after simplifying that c4, or in another manner where c4 is there, if you substitute this value of c3, then c4 will be obtained. After knowing c3 and c4, substitute in the deflection equation, in the slope equation, it is c3 is there, we have to substitute c3, and in the equation, that is deflection equation, c3 and c4 both. So let us simplify. C4 equal to, in that equation, c3 times l. What is the c3? ei theta c minus wb a square by 2l. wb a square by 2l. Now c4 equal to wb cube by 6 minus wb l square by 6 minus, this is the c3 value, wb cube by 6 minus wb l square by 6 minus, make it l multiply ei theta c l, minus into minus plus, that is positive, negative into negative, that positive, wb a square by l get cancelled, that becomes 2. Now wb cube here, wb, make it common from these two terms. If you make it wb by 6, then is a b cube, it becomes a b square, l square. This is the term. Now ei times theta cl plus wb a square by 2. Now further here again, wb by 6 b square minus l square. Now you send this term this side, that's plus wb a square by 2 minus ei l times theta c. This is c4. Now next step. What is the next step here? Here WB common is there. Here also WB. Make it common WB and by 6. Here it is 2 is there. How to make it? You multiply with 3, then 3 by 6 it becomes 2. So W by 6, you can make it common. WB by 6, B square minus L square plus 3A square. Then what happened? WB 3A square by 6, that is WB A square by 2. That is common term, that is EIL times theta C. Now further simplification, what we are going to do here, C4 equal to, in the place of L, what is the total span? Total span, that is L equal to A plus B. That is L equal to A plus B. Now in the place of L, substitute A plus B, that is WB by 6 times B square minus, in the place of L, substitute A plus B whole square plus 3A square minus EI times L times theta C. Here WB by 6, further B square minus of this A plus B whole square, that is A square plus B square plus 2AB, and multiplied with the negative sign, the minus A square minus B square minus 2AB. This is the term. Plus 3A square minus EIL times theta C. Now again WB by 6, step by step. Here make it common. What is the make it? That is B square plus 2, negative B square cancelled. 3A square minus A square, that is 2A square minus 2AB time minus EIL theta C. Now again, what is the common here? 2A make it common out, that is WB by 6, 2A common, A minus B minus EIL theta C. Now WAB by 2 and C get cancelled, that is 3 times WAB by 3 of times of A minus B minus EIL theta C. This is C4. Now we got C4, substitute this C3 and substitute this C4 in the equation. Okay, substitute this value wherever dy by dx C4 is there. Where is the equation C4? The C4 here it is and C3 and also C3 here. After substitution, we get the equations EI and the slope equations and deflection equations. Now, after substituting C3 in equation 6, yes, equation, this is the C3 value. Okay, that is the C4 value, we got it. Now C3 value if you substitute, that is EI times dy by dx equal to dWB by times 2L, WB by 2L times x square minus W by 2 x minus A whole square plus EI theta C minus WB A square by 2L. Now we know the equation and substitute C3 and C4 in equation of deflection equation. This is the C3 and it is the C4 value both in the equation. This is the equation number, where is the equation number 7. Then the deflection equation is obtained, will be obtained. Now this is the deflection equation. EI times WB by L, that equal to the deflection equation, that is EI times deflection equation. Then after that EI times WB by 6L x cube minus W by C x minus A whole cube plus EI times theta C is the C3 and it is C4. So the deflection point C obtained at x equal to A in the above equation, let YC the deflection at C, hence we get that EI times this is Y, EI times Y equal to, then EI times YC equal to, this is EI times YC, here it is EI times Y. Now EI times YC equal to WB A cube by 6L x equal to A, substitute. Then W by 6 A minus A whole cube plus Y x equal to A. We need deflection. The concentric load is acting at a distance of A from left support. EI times theta C minus WB A square by 2L by times A plus WAB by A minus B minus EIL theta C. Now the YC becomes 1 by EI times WB A cube by 6 WB AQ by 6L minus A minus A 0. This term becomes 0 plus EI times theta C minus WB A cube A into A square into A cube by 2L plus W times AB by 3 times A minus B and this term. These are the common terms, same as usual. Now 1 by EI WB AQ by 6L, now it becomes 0 and another term is here WAB cube by 2L and WAB by 3 times A minus B. This is EI times A theta C. This is the A theta C and it is L theta C. Now what is the common here? EI theta C is the common, that is alpha A minus L, not alpha. Now further simplification, okay, and this x equal to A, the point C also can be obtained if you substitute x equal to A in equation 5. That here, after getting in equation, after substituting in equation 5, what is the equation 5 here? This is equation 5. So from that, after substituting equation 5, that is EI times YC equal to WB AQ by 6L plus EI times theta C minus WB A square by 2L times A. Further simplification, YC equal to 1 by EI times WB AQ by 6L plus EI theta C. This A enters inside A minus WB AQ by 2L. This is YC. Now there are two equations. This equation A also in YC and this is equation B also in deflection at C. Equate both equation A and equation B, then the theta C will be obtained. After equating A and B and after simplifying it, then we got to know WB AQ by 6L, WB AQ by 6L. So WB AQ by 2L, it is also minus minus. Then finally obtained here, this is the value. EIL times theta C equal to WAB by 3 times A minus B. This is theta C value. Theta C equal to WAB by 3IL times A minus B. This is the slope at where? Point C, that is where eccentric load is acting. Theta C. Now after knowing theta C, if you substitute this value in the deflection equation, this is B, either A or B, theta C value substitute and simplify, we will get the deflection at C. Now this is the theta C. The equation theta C, substitute in any equation, either deflection equation, equation 4. If you substitute, then what is the equation 4? Or you can substitute in the B also and simplifying will get it. Where is the equation 4 here? This is the equation 4, theta C value. This is theta, this is the slope equation. Equation 4 is wrong here. Deflection equation 5, if you substitute, deflection will be obtained. So what is the deflection here? EI times dy by dx. After substituting theta C value, that is EI times WAB by 3IL times A minus B minus WB A square by 2L. And simplifying it, then the final equation, this is the deflection, that is WB by 6L. Okay, that is 3x square minus 2ab minus a square. Now, at the length AC is more than the length CB. Hence, maximum slope will be at the support A, where x equal to 0. Let the support at A is represented theta A. Hence, dy by dx at A will become theta A. Now, at x equal to 0 substitute, then the slope at A is, this is the value obtained. That is minus WAB by 6EI times L times A plus 2B. How we got it here? Again, EI, equation C is here. That is EI into dy by dx at A. That is EI into dy by dx. EI times, this is the equation. In this equation, substitute x equal to 0. Why x equal to 0? Because at x equal to 0, the maximum slope can be obtained. That is theta a. That is ei times dy by dx at x at a. Wb by 6l times 3x square. X equal to 0. 3 0 square minus 2ab minus a square. Ei theta a equal to wb by 6l minus 2ab minus a square. That is minus, if you make it, w, make it a common, wab by 6 ei times l into a plus db. This is the slope at support a. Negative sign with the slope means, here what is the negative sign indicates? Negative sign at the slope means the tangent at the point A makes an angle in the anti-clockwise direction or negative direction. How here it is, we can see. The tangent, it is in anti-clockwise direction. This is the anti-clockwise direction. Yeah, negative sign indicates the anti-clockwise direction. So that is what meaning here. That is the negative sign. Now, value of maximum deflection we want. Now substitute the A and B. Since A is more than B, so hence maximum deflection will be, A is more than, will be where? In the portion of AC. So the deflection at any point in the length AC is given by the equation 5. That equation 5 is here. This is the deflection equation. And here, theta c, if you substitute here, after substituting theta c value and simplifying it, what is theta c here? WAB by 6EL times A minus B. EI times WAB by 6EIL times A minus B minus WB A square by 2L. And simplifying, by simplifying it, EI times Y equal to WB x cube by 6L plus WAB by 3L. EI get cancelled of A minus B minus WB A square by 2L times X. Further simplification, WB by 6L, make it common, WB by 6L. That this is x cube term, because it is 6 and it is 3. So make it multiply with the 2a, that is 2 times 2b already common, 2a times a minus b times x coming inside, x minus WB by, it is 2l. How much we have to multiply? 2 means here 3. 3a square, b went outside common, that is 3a square x. WB by 6l times x cube plus 2a into a square, 2a square x minus 2abx minus 3a square x. Now here there are two terms. One is negative 3a square x, positive 2a square x. That means 1 minus negative a square x. X cube minus a square x minus 2abx. That is ei times y. Now WB by 6l times x cube minus a square, that x common, a square plus 2ab. This is the term. Now, further simplification, then y equal to, that ei comes to right side, that is WB by 6EIL x cube minus x times a square plus 2ab. Now the deflection will be either max or minimum where dy by dx equal to 0. Now if you derivate dy by dx equal to WB by 6EI times L 3x square minus x, that is minus of a square plus 2ab. Now the maximum deflection, as if you equate to 0, dy by dx equal to 0, then x value comes. The x value is obtained here it is a square plus 2ab and the square root of a square plus 2ab by 3. Substitute this x value where? To get the maximum deflection. Here, the maximum deflection are here. This is slope will be dy by dx equal to 0. The maximum deflection in this equation. Then after substituting in that equation is the D equation. Okay, after substituting we will get y maximum. What is the y maximum? WB by 6EI times L, x value, that is under square root of a square plus 2ab by 3. And simplify it. This is the y maximum value. The y maximum is, here it is WB by 9 times root 3 EI by L, EI times L, A square plus 2AB power 3 by 2. Now here it is negative, that means the downward direction. This is the maximum deflection value or equation. This equation indicates the maximum deflection in the downward direction. Now deflection at under the point load. What is the deflection under the point load? Where x equal to a, substitute in that equation. Now yc equal to wb by 6a times l minus times x cube minus x times a square plus 2ab. Here if we want under the point load, the concentrated load at a distance of x equal to a from left support, substitute x equal to a, then a cube minus a times a square plus 2ab. So this a cube minus a times a square, that is a cube minus 2a square b. Both will be cancelled. That is w a square b square by 3I times l. That is the downward direction here. Now here the yc is deflection at point C is w a square b square by 3I times l. So downward direction, that's a negative sign. This is the deflection equation at the concentrated load, that is eccentric load, which is at a distance of A from left support and B from right support. At this point C, the deflection is yc. The yc value is w a square b square by 3I times l. This is the derived deflection at point C where concentrated load is acting. Okay, this is the formula w a square b square by 3I times l. So here the method we found by using double integration method we use. For eccentric load, it is so laborious, we can observe. We found theta c value, and again we found two times double integration applied here at a distance span of A and C between section at A to C, and again at section C to B. Then in order to find out the slope at C value, after getting slope, we have to find out the maximum deflections. So deflection at point C is observed here is w a square b square by 3I times l. So which one is the simple method for this type of things? So there is another method is called Macaulay's method. In this Macaulay's method is very simple method. We can see it in next sessions. But in this section we derived here. So let us find out what is the slope. We found that slope at A, it supports at the slope, the maximum slope. That is, this is the formula for slope. This is at supports A, the maximum slope at support A is observed, that is WAB by 6I times L, A plus 2B. So here, and deflection, let us find out how to apply those formulae in solving the problems. Okay, let us see here. Determine a slope at the left support and deflection under the load. A third objective is maximum deflection of a simply supported beam of length 5 meters, which is carrying a point load of 5 kilonewtons at a distance of 3 meters from left end. Take the properties modulus of elasticity is 2 into 10 power 5 Newton per square millimeter, and moment of inertia I equal to 1 into 10 power 8 millimeters per 4. So these are the data is given here, and how to find out the slope at the left support. Why it is left support? Because the maximum slope is taking place at left support. The span of the beam is 5 meters, but the concentrated load is acting at 3 meters. So in this manner, let apply here. That is the homework for the students. You apply the same formulas. What is the formula here? Theta A equal to WAB by 6I times L times A plus 2B. Substitute, directly we get the answers. So in this session, what we have studied here, we used a double integration method and found the maximum deflection, the maximum slope, and also deflection and slope at the concentrated load or eccentric load which is acting at a distance of A from left support and B distance from right support. Here A is greater than B. Therefore, it is observed the maximum slope occurred at the support A, and derived formula for slope at concentrated load, and also maximum slope, maximum deflection for the case of simply supported beam with an eccentric point load. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.